Welcome. Let's solve some problem from one-dimensional motion. Basically, there are three equations of motion and 5 different physical quantities are related. First one is initial velocity is v naught, final velocity is v, time of travel t, acceleration a, and displacement, which is along x direction, delta x, which is difference of final position and initial position. To use this equation in a problem, first make a sketch of a problem which is easier to visualize. Second one, decide the positive and negative direction. So to assign positive and negative values for vectors. Generally, the east direction or right hand side of your screen is positive x-axis, which you can take as positive, and west side or left side is actually negative. We can take as the same thing, north side or top side is positive and downside or south side is negative. The third one is write down all the values which are given with symbols and also mention what quantity you have to calculate. Fourth one is verify there are at least 3 quantities are given out of 5 and identify again what is asking. So every equations in equation motion 4 quantities are related, so choose appropriate equations with 3 quantities are given and what you have to calculate. And next thing you have to remember is if a motion is divided into segments, then you can treat each segment individually. And so to solve this equation of motion, remember the final velocity of previous section is initial velocity of next section. And there are certain things you have to remember. If a body starts from rest, then its initial velocity is 0. And if a body stops, then its final velocity is 0. Similarly, if a body is moving with uniform velocity, uniform means same, then there is no change of velocity. It means its acceleration is 0. And on the other hand, if a body is retarded, then its acceleration is negative. So retardation means its velocity goes on decreasing over time. So it means final velocity is less than initial velocity. After knowing this, let's solve our first problem. So in this case, this object is moving east, so you can make a sketch at first. So it is moving along east direction, which is positive value 18.5 meter, and then it returns back west direction less than this value, which is 12.1 meter. Now it is asking what is the distance traveled and what is the magnitude of displacement. So first you have to remember is the distance traveled is just summation of absolute values. So which is 18.5 meter, and it is scalar quantity. You don't have to take positive and negative sign, just add whatever travel it does. So 18.5 meter in east plus 12.1 meter west. So add them together. So you will get 30.6 meter. This is distance travel. On the other hand, if you want to calculate displacement, you have to assign its direction. So this is east direction, which is positive, and this is west direction, which is negative, because displacement is vector quantity. So if you want to calculate displacement, then that is sum of two values with their sign. So plus 18.5 meter minus 12.1 meter. That is, if you subtract them together, then you get 6.4 meter. Now this is less than distance traveled. Next thing you have to remember is the final answer is positive. So it means the direction of displacement is along east, because we are taking east is positive. So this is displacement magnitude, and if someone is asking its direction, then it should be east. Now let's go to the next problem. So in this case, the car is traveling north. 17.7 meter per second, 17.7 meter per second, which is initial velocity v naught. So after time 12 seconds, the velocity becomes 14.1 meter per second in the same direction. So now you can take both are positive. Now you have to calculate what is the direction of acceleration and what is its magnitude. So look at here, three quantities are given: initial velocity, final velocity, and time. Now you have to calculate acceleration. So there are three equations of motion. So you have to choose one equation which relates velocity, two velocities, initial and final velocity, time, and acceleration. So which is this equation? So write down this equation: v is equal to v naught plus at. So if you solve them by substituting these values, v is 14.1 is equal to v naught is 17.7 plus a times t is 12. Now solve this equation, or 14.1 minus 17.7 is equal to 12 times a. So 12 times a is equal to, if you subtract them, 14.1 minus 17.7, you will get negative 3.6. So a is equal to negative 3.6 divided by 12. That is equal to negative 0.3. The unit of acceleration is meter per second square. Now 0.3 meter per second square is value of acceleration. So you can see over the negative sign. So this negative sign indicates the direction of acceleration is in south. So which is opposite to the direction of velocity. So look at here, initial velocity is higher than final velocity. So it is retarding. So we do get acceleration is negative value. Now let's go to the third problem, a little bit more difficult. So in this case, the car accelerates starting from rest. So you do have already a v naught is equal to 0 meter per second. Okay, with constant acceleration, a is equal to 2.0 meter per second for 15 seconds. So t is equal to 15 seconds. Now in this case there are two sections. One is the first section, so going from, let's say, A to B. So it has initial velocity is 0 meter per second, accelerating with 2 meter per second square, and time is 15 seconds. Now first one is you have to calculate at point B in A what is the velocity. Yes, at the end of this time, what is its velocity? Now there is another second section there. So after time t is equal to 3 seconds, the car stops. At point C, its final velocity is 0. Yes. Now you have to calculate what is its value of displacement at this section. Now we can treat these two sections separately. First solve this A to B and B to C. So let's go back to the A to B. Now in this case, three quantities are given over here and you have to calculate V. Now try to find out equations which is related to V naught, A, T and V, which is equation first. So use equation first. B is equal to V naught plus A times T. So V naught is 0 plus A is 2.0 times T is 15. So 15 times 2 you will get 30 and velocity is meter per second. So at the end of this section first at point B, its velocity is 30 meter per second, which is final velocity of this first section. This is first section. Okay, first section means x section AB. Now go back in second section, which is section BC. Now in these sections, the time is given, final velocity is stops, so its final velocity is 0. Now you have to calculate delta x, which is displacement. Now you need at least three quantities to calculate the other one. So we do have only two. So from the first sections you have to find out the another quantity which is related to second section. So look at here, this final velocity in first section is 30 meter per second. Yes, 30 meter per second. Now final velocity means at point B. Now this is initial point of section BC. So in section BC, its initial velocity is equal to final velocity of first sections, which is 30 meter per second, and we have given time to travel is 3 seconds, and final velocity it stops, which is 0 meter per second. Now you have to calculate delta x. Yes, delta x, which is displacement, is equal to what? Now you can find out equation which is related to this 4. Now if you look at any equations, v naught, t, v and delta x, there is no any equations, so you have to calculate other value and relate that again. So I'll use first equation, calculate first a, and use third equations, use this value of a to calculate delta x. So if I use v is equal to v naught plus at, v is 0 in these sections, v naught is 30 plus a is unknown and time is 3 seconds. So if you use this equation, negative 30 is equal to a times t. I'll solve over here. So it means a times 3, so which is 3a. So a is equal to negative 30 divided by 3, which is negative 10 meter per second square. Now you can use this value to equation third, which is v square is equal to u square plus 2a, no, v square is equal to v naught square plus 2a delta x. Okay, so this v is in second section is 0 square is equal to v naught is 30 square plus 2a is negative 10 times delta x, which is 0 is equal to 30 square is 900, 10 minus 10 times 2 is 20 delta x, yes, then delta x is equal to 900 divided by 20, which is, you will get 900 divided by 20 is 45 meter. So the car stops after traveling 45 meter in traffic light. So these are some problems in x direction. So we can similarly we can do the same problem in free fall motion. Free fall is vertical motion. If you drop anything from height, or if you project anything vertically upward, then they are called free fall motion. There are certain points you have to remember in free fall motion. Just like one, an object is in free fall as soon as it is released, where it is dropped from rest, thrown downward or thrown upward. And free fall motion is constant downward accelerated motion, and its acceleration is equal to acceleration due to gravity, and in earth, which is constant quantity, and the value of g is 9.8 meter per second square on the earth's surface, and its value is different for different planets as well as on the moon surface. And the free fall motion is long y direction. So you can change all the equation of motion by assigning a is equal to g and x is equal to y for free fall motion. And I'll tell you, this a is equal to g is sometimes negative g or positive g, depending upon either it is towards the earth or away from the earth, because acceleration due to gravity is always acting towards the earth. So if you are moving away from the earth, then you have to put a is equal to negative g. Now next thing is, if an object is dropped, not thrown, from a height, then its initial velocity is 0, because you will drop from a height, so it means you just release. So initial it's rest, so its initial velocity is 0. Similarly, if an object is thrown vertically upward, then its final velocity is 0. That means velocity at the top point is 0. It means you can easily conclude the velocity of an object and the highest point is 0. So either you drop or if you throw up. Another thing is, if an object is thrown vertically upward, then gravity is always acting towards the earth, so its velocity continuously decreases and becomes zero at the top point. And similarly, when it drops from height, then its initial velocity is zero and continuously increases. From zero and reach a maximum value when it hits the ground. Now let's do one problem. Starting from first. A stone is thrown with an initial upward velocity 7 meters per second. So it's moving up. So its initial velocity is 7.0 meter per second. And we are not considering air resistance. So you have to calculate velocity after .50 second. Okay, so you have to calculate final velocity. Now if you look at this equation, only two quantities are given, so third quantity should be there. So which I told you earlier, the acceleration, you can replace acceleration by acceleration due to gravity, and there should be either positive or negative sign in front. So if a body is moving up, so it is opposite to the acceleration due to gravity, so you can replace a by negative g, which is negative 9.8 meter per second square. And same thing over there, you can replace x by y because it's vertical motion. So x naught is replaced by y naught and x is replaced by x, or delta x is replaced by x is replaced by y, as well as delta x is replaced by delta y. So in this case, v naught, a and t is given, so you have to calculate v. So which equation you want to use? Which is equation first. So you can modify this equation. So v is v, v naught is also v naught. So a is g, but it's vertically upward motion, so which is negative g, and time t is t. Now v, which you have to calculate, v naught is given 7.0 meter per second, and is negative g, which is g is 9.8 meter per second square, and time is given after 0.50 second. So this is 7.0 minus 9.8 times 0.50 is 4.9, and 7 minus 4.9, you will get 2.1, and velocity is meter per second. So look at here, the initial velocity is 7 meter per second, and after 0.5 second it's continuously decreased and becomes 2.1 meter per second, and its value is still positive, so it's still going up. Sometime you'll get its negative value. It means the body, the stone, is the maximum height and again falls down, so it's negative, the velocity is in downward direction. Now let's do the little bit more difficult problem again further. So in this case, ball is projected vertically upward from the roof of building. Okay, so there is a building which is 90 meter tall, and body is projected from here, ball is projected from here to up, and it reaches maximum height and falls down and reaches the ground. Okay, this is ground. This is going from here to here. Okay, so initially there are two sections of problem. So going from A to B, going from top of the building to the maximum height, and going from B to C, from maximum height to ground. So you can treat them individually and solve them together to find out the total time going from A to C. So let's take a section first, this A to B. So in this case it's given first sections, yes, section AB. Okay, so this ball is projected up with initial velocity 80.5 meter per second. Now it is moving up, so you can replace A is equal to negative G, which is minus 9.8 meter per second square. Now next point is it's reached the maximum points at point B, where the velocity, this is initial velocity 80.5 meter per second. So at point B its final velocity is 0. So it becomes 0 and changes direction. Now we have to calculate time go from A to B and B to C. So let's calculate time going from A to B. So it means you have to calculate time t. Let's say I'll calculate t is equal to what in this section. Okay, so we have V naught, V and A. You have to calculate t, so you can use equation first. So V is equal to V naught plus AT, which is V0 plus V naught is 80.5. A is negative G, which is negative 9.8 meter per second square times T. Now negative sign. So and you solve it, 9.8 times T is equal to 80.5. So it means T is equal to 80.5 divided by 9.8. If we divide this 80.5 divided by 9.8, let's do the calculator. So I got it is 8.2 seconds. Okay, to make sure this second, so I just wrote this SEC, don't confuse it with 5. So to go from A to B, it will take 8.2 seconds. So we have to calculate how long the ball remains in air. So we are calculating from A to B only. So let's take how long it will take to go from B to C, and total time is sum of these two. Now in second sections, let's do the problem in BC sections, in which case the ball moves from top of the points to the ground. Now in this case we do have the initial velocity at point B. For BC sections, whatever velocity at point B, which is initial velocity, which is actually a 0 meter per second. That means the final velocity of AB sections is initial velocity of BC section, and A is G, positive G, because body is moving, the ball is moving from downward direction from B to C, so it's along the direction of gravity. So that is 9.8 meter per second squared. Now we don't have third quantity right now, so to calculate T we need third quantity. So let's calculate the height from B to C by using the information from first section. So from A to C is the height of building, which is 90 meter given. So let's calculate from distance from A to V from the first section. So in first section, if you use equation B, the third equation of motion, B square is equal to V naught square plus twice A delta x. So you can write this in y direction. V square is equal to V naught square plus twice A is you can replace by negative 9.8, and delta x is actually delta y. Yes, so it's moving from A to B is moving up, so delta y is positive. So B is equal to 0, 0 square is 0, and B naught is actually a 80.5. So let's do 80.5 square is equal to negative. So negative there. 9.8 times 2 is, alright, just add it. 2 times 9.8 times delta y. Yes. So if I solve over here, 2 times 9.8 times delta y is equal to 80.5 square. So it means delta y is equal to 80.5 square divided by 2 times 9.8. So if I am using calculator, so how much do I get? Now let's do this. 80.5 square divided by 2 times 9.8. In my calculator I got 330.63 meter. I'm rounding off. So look at here, from A to V is 330.63 meter. So from A to C is 90 meters. So in second section from B to C, the displacement delta y is equal to total from here to here and here to here, which is 330.63 plus 90 meter, which is equal to, by using calculator, 420.63 meter. Now I do have V, A, and delta y. So now I have to calculate T. So you can use second equation of motion, which is you can replace x by y. So y is equal to y naught plus V naught T plus half, and this is along the reaction motion, so g t square. So this you can replace y minus y naught. This delta y is also y minus y naught. Yes, is equal to v naught t plus half gt square. Y minus y naught is delta y, which is we do have is 420.63 meter, is equal to v naught. Initial velocity is 0, so everything is 0 in this case, plus half g is 9.8 meter per second square times t square. So if I solve for t, what do you get? 2 times 420.63 divided by 9.8, and I do have a square, so you can take a square root on both sides. So if I solve this, 2 times 420.63 divided by 9.8 your calculator. In my calculator I got is 9.27. This is in second. Yes, so look at this section AB and BC. So going from A to B, it will take 8.2 seconds. So going from B to C, it will take 9.27 seconds. So total time of travel. The ball remains in air. How much time? So total time. The ball remains in air is equal to sum of this. So 8.2 seconds going from top of the building to the maximum height plus 9.2 what's happening, 27 second. Yes, 9.27 second to go from top to bottom. So if you add them together, so you will get 17.47 second. So it will take 17.47 second to go from A to B and B to C. That means the ball remains in air for 17.47 seconds before hitting the ground. Alright.